Okay, so today we're going to talk about integer operations. And so integer operations are our four basic operations that we should know before, which is addition, represented by the plus sign, subtraction, represented by the minus sign, multiplication, represented by a dot, and then division, represented by the division symbol. Now, we're going to learn a few rules, but I think overall it should be pretty straightforward. This is actually one of my favorite topics in mathematics, and we'll start off with addition. And so with addition, I'll write that down here, addition. When it comes to adding integers, it really only depends if the numbers that you're adding all have the same sign or if they have a different sign. So for example, if we have the numbers 4 and we're adding 6 to 4, so 4 plus 6, that's very similar to what we know before. In fact, it's exactly the same to what we know before, which is just 10. 4 plus 6 is 10. Now, if they have a negative symbol in front of them, so for example, -2 plus -5, then -2 plus -5, we can simply just not think about the negative number, the negative sign in front of it, and say, well, 2 plus 5 is 7, and then simply add the negative back. And so then we get -7. So to repeat that, if I have two negative numbers, let's say -4, and I'm adding -5, I can just not think about the negative numbers in front. Sorry, the negative signs in front. I keep saying negative numbers, but it's negative signs. So negative signs in front, I just forget about those. I say, what's 4 plus 5? That turns out to be 9. And then I add the negative number back. So that becomes -9. The challenge when it comes to adding integers is when they're of different signs. So for example, if I have the numbers 4 and -2, I'm trying to add them. So 4 plus -2. What we have to do first is we have to draw a number line. And we have to say, okay, let's count out 4 spots from 0. So we start at 0 and we go 1, 2, 3, 4. And then with our -2, we then have to count back 2 spots. So we're then going to count back 2 spots from 4. We start at 4 and then we count back 2. So we go 1, 2. And our answer becomes 2. Okay. Now, if I start with a negative number and then have to add a positive number, it's very similar, except we just start our number line on the negative side of 0. So for example, I'm going to go down to a new line here. If I have -7 plus 5, right? So I'll do white for this, -7 plus 5. We'll start on the negative side of 0. So I'm going to give myself a lot of room here. We have 0, then we have -1, -2, -3, -4, -5, -6, and then at the very end here we have -7. Okay. And so since we start at -7, now we have to count forward 5 spots. So we're going to go 1, 2, 3, 4, 5. And we end at -2. And so then -7 plus 5 is -2. Okay, so to recap on addition, if they have the same symbol, whether it's positive or negative, we add them like we always did, and then add back their sign afterwards. So if it's positive, it remains positive. If both of them are negative, they remain negative. If they are of different signs, so if one is positive and one is negative, then we get to use our number line. Okay? And so now we'll move on to subtraction. And so for subtraction, we have some pretty interesting rules for when it comes to subtracting integers. So let me go ahead and get my white here. So for subtraction, first off, if we're adding them, it's kind of straightforward. Oh, sorry, yeah, we already talked about adding. So if we talk about subtracting numbers, we have a specific rule that we have to do. Now, if the first number is bigger than the second number, so for example, if we're subtracting 5 minus 3, then it's very similar to what we've done before, which, as we all know, 5 minus 3 is just 2. However, there's a rule that we can implement here now that we know about negative numbers, where we can say 5 minus 3, we can do something to this sign right here. We can make the operation addition, so make it addition, and then change the sign of the second number. Okay? And so what would that look like? Well, 5 minus 3 in this case would then become 5. We would take the subtraction sign and make it positive, so it would become plus, and then we would make the 3 negative, so it would become plus negative 3. And then we would add it like we just did above. Okay? So we would get our number line out. We would start at 5, and I'm going to do this really fast. 1, 2, 3, 4, 5. 0, 1, 2, 3, 4, 5. And then we go back 3 spots. So we go 1, 2, 3. And we get positive 2. Now you're going to ask me, why did we just have to do that? I already know that 5 minus 3 is 2. So why do I have to do all this special work to just know what I knew before? Well, the problem when subtracting integers is sometimes we can get into a scenario like this, where we have 3, and then we're subtracting 7. Where the first number is smaller than the second number. And so in this case, it makes more sense to follow the method I did above, because 3 minus 7 is not easily obvious to us. In fact, it's smaller than 0. But if we do the method above, where we take the operation, make it addition, and then change the sign of the second number, so we get 3 plus negative 7, then we can use our number line. I'm going to put 0 in the middle here, so we're going to get 0, 1, 2, 3, and then I'm going to go out a certain number of spaces on the negative side. Negative 1, negative 2, negative 3, negative 4, and negative 5. If we use our number line now, we count out to 3, so we go, here's 3, and then we go back 7. We go 1, 2, 3, 4, 5, 6, 7. We now see that 3 plus negative 7 is now negative 4. And that's not immediately obvious to us if we just try to do what's 3 minus 7. We don't immediately know that it's negative 4, but with the use of our number line, we can see definitively that it is negative 4. And so that's the trick when it comes to subtracting integers. If you're subtracting integers in which the second number is bigger, you have to use the number line, and you have to follow these two rules. You have to change the operation from subtraction to addition, and then change the sign of the second number. Okay? And so now let's get to multiplication. And so for multiplication, we have a few different rules. So let's see. So for multiplying, you don't need to know exactly why these rules work, at least not yet, but we just need to know that they exist. And so the first rule is that obviously we know that a positive times a positive, so a positive denoted by the plus symbol times a positive is positive. The second rule is that a negative denoted by the minus sign times a positive is negative. And then the third rule is the vice versa of that, which is a positive times a negative is also a negative. And then a negative times a negative is positive. Okay? As long as we remember these 4 rules here, we can do multiplication. So I suggest you write them down on a sheet of paper, or maybe in an index card or somewhere in your notes. And then from there, you should be able to multiply any 2 integers together, or really any 2 numbers together, regardless of their sign. But we'll have a few examples here. So I'll start off with, let me go down to a new line here, or a new page. Let's see. Let's say negative 3 times negative 2. So remember, it's a negative times a negative. So a negative times a negative is positive. I'm going to remove this little dot that showed up. So a negative times a negative is a positive. So then we say, well, 3 times 2 is 6. A negative times a negative is a positive, so we get 6. And so then if we say, well, what's negative 3 times negative 1? Well, we say, first off, what's 3 times 1? That's 3. And then a negative times a negative is a positive, so we get 3. And I mean, I can continue this a few more times. So if we do what's 4 times negative 2, we see that's a positive times a negative. And so a positive times a negative is negative. And then the multiplication of the 2 numbers, 4 times 2 is 8. So then we get negative 8. And then vice versa, if I get negative 5 times 4, we say 5 times 4 is 20. And then a negative times a positive is negative, and we get negative 20. Now, remember, I told you that you didn't have to understand why these rules work. I'm going to show them to you, how these actually work. But you probably don't necessarily need to know this. So, if you don't feel like following through with the next portion, you can skip ahead to division, which will be later in this video. But let's just say that I have the number negative, actually I'm going to start with positive 3 times negative 5. Okay. Well, what we have to remember is what really is multiplication. And multiplication is a repeated addition. And in fact, this case, it's -5 plus -5 plus -5. And so then -5 plus -5 plus -5 becomes -15. And that's why free times -5 is -15. Now, additionally, if we flip this around and we say, well, what's -5 times free? Well, that would be free added 5 times, but then negative. So it's, in this case, it's free plus free plus free plus free plus free, which is 15, but then it's the negative of that. And so then we get -15 because we have -5. Okay. Now, additionally, if we're looking at a negative times a negative, so let's say we have -4 times -2, then this is, I need to remember my, this is -2 plus -2 plus -2 plus -2, which is then -8. But remember that we're taking the opposite of whatever this sign is, and so then it becomes +8. And so that's why a negative times a negative is a positive. Okay. Side tangent over. It's okay if you don't completely understand that, but that's part of the reason as to why a positive times a negative is negative and all the other jazz. Now let's get on to division. So let's talk about dividing numbers, and then that will end it for this video. So division is very similar to multiplication. And so we're going to have 4 rules here also, and they're basically the same rules that we used in multiplication. So the first rule is a positive divided by a positive is a positive. The second rule is that a positive divided by a negative is a negative. The third rule is that a negative divided by a positive is a negative. And that the fourth rule is a negative divided by a negative is now a positive. Okay. Okay. And so, simply put, we can have a couple of examples of this. So if I say what is 12 divided by 4? Since they're both positive in this case, we simply divide them as we've always known, and it becomes free. If I'm looking at what's -12 divided by 4, we say, well, that's using our rules above, it's a negative divided by a positive, which is simply a negative, and so we're going to get negative free in this case. If I have 2 different numbers, and let's say I'm doing 20 divided by -5, 20 divided by 5 is 4, but a positive divided by a negative is a negative, so we get -4. And then if I have -20 divided by -5, I get 4, because a negative divided by a negative is 4. Now, similar to what I did with our multiplication counterpart, I'm going to explain to you as to why these rules actually work. And I'm only going to show it briefly, and it's okay if you don't understand this. You can actually end the video here if you want. But let me go ahead and explain something. So, if we have a division equation, so for example, 6 divided by -3 is equal to 2, remember that division undoes multiplication. So division and multiplication are related to each other. And actually, this needs to be a negative. I forgot about that. That is a negative. -2. 6 divided by 3 is -2. And so what this equation undoes is actually the multiplication problem. -2 times -3 is 6.